So, good morning. So, for today's lesson in chemistry, we will tackle about the colligative properties of non-electrolytes solutions, which is in boiling point elevation. So, for the learning objective in this lesson, we or you should be able to describe and discuss the effects of a solute on the boiling point of a solvent. We define first what is the boiling point. Boiling point, it is the temperature at which the vapor pressure of a liquid is equal to the pressure of gas above. So there are two main points from boiling point, which is the normal boiling point and boiling point elevation. Normal boiling point is the temperature at which the vapor pressure of a liquid is equal to 1 atmosphere, or 760 torrent. Boiling point elevation is when a solute is dissolved in a pure solvent, the boiling point of the solvent will increase, and it can be also described in terms of vapor pressure. So, when it comes to calculating boiling point elevation, this is the equation we use. The difference between the boiling point of a solution and a pure solvent can be written as delta temperature is equals to Tf minus Ti. So in calculating the boiling point elevation, we have this equation. This change in boiling points between a pure solvent and a solution is directly proportional to molar concentration of the solute particles. So this equation is gamito nato later. We will gonna use this equation para makabalo ta kung unsaon pag-calculate sa boiling point elevation. Since boiling point elevation is colligative property, the boiling point elevation constants are also properties that depend on the identity of the solvent. So here are the values of boiling point elevation for some solvent are listed. For the solvent, water, we have the boiling point or the temperature at 1 atm is equals to 100, and of course the boiling point elevation is equals to 0.512. We have the hydrogen acetate 118.1, 3.07. The benzene is the boiling point is 80.1 and the Kb is 2.53. And the last one is the chloroform, which is 61.26 and 3.63. So kani sila na mga boiling point and a solvent is constant sila. Muna sila nga numbers ang atong gamiton to solve this the Kb, which is katong nasa atong equation ganina. So let's proceed to the let's practice the example number 1. For the example number 1, we have to calculate the boiling point of an aqueous solution where enough lactic acid is added to make 0.37 mole solution. The Kb for water is 0.512 degrees Celsius per m. So the given here is the Kb of water, which is equal to 0.512 degrees Celsius per m, and also the mole solution, which is the 0.37 m. M dira. So as you can see sa tong equation, we have the equation here is the working equation here is this one. So the main problem here is we have to calculate the boiling point. So the formula or the equation for boiling point is this one. So now we have to substitute the values. For the Kb, we have 0.512 degrees Celsius per m, and we have the mole solution is 0.37270 m. So we can come up the answer by 0.19 degrees Celsius kasi makancel ang M there, so mabili na lang is degrees Celsius. So now let's try it. So calculate the boiling point of an aqueous solution wherein a lactic acid is added to make 0.40 mole solution. The Kb for water is 0.512 degrees Celsius per m. So let's answer. For example number 2, what is the boiling point elevation when 120 grams of lactic acid is dissolved in 600 grams of cyclohexane? The boiling point constant for cyclohexane is 2.79 degrees Celsius per m, and the boiling point of a pure cyclohexane is 80.74 degrees Celsius. So we have the given here, the both lactic acid and the cyclohexane. The lactic acid is equals to 120 grams and the cyclohexane is equal to 600 grams. And also, the Kb, or the boiling point of cyclohexane, is 279 gigacelsius per m. And also, the boiling point of a pure cyclohexane is 80.70 degrees Celsius. So as you can see, there are no given molar solution here. So firstly, in this equation or in this problem, to look we have to look for the molar solution first before we proceed to the working equation. So now we must find the boiling point elevation, what that is the problem. So now we have to solve first for the molar solution. So how can we solve for the molar solution? So we have to divide this both side by Kb. So Kb. Then we have to cancel this one Kb here and Kb. So the ang M na lang ang maiiwan. So we have the working equation is M is equals to delta TB divided by KB. So this one will become up with this. So are you uh, confused on where we get this 162 grams per mole? So we get this by multiplying the molar mass in the periodic table, that's as we see here, on the lactic acid and the cyclohexane. So the lactic acid has C6H10O5 and the cyclohexane has C6H12. So we have to multiply that on the molar mass that you can see on the periodic table, and if you get the answer of all that, you have to add that, and we get the answer 162 grams per mole. So I will gonna explain it to you later for the try it number 2. So here we are how to get the molar solution or molality of solution. So we have to substitute the given values for 120 grams and 162 grams per mole here, and of course here 0.600, or we can have it zero point 0.6. So how can we come up with that 0.600 kilograms? So as you can see sa given na to, ang cyclohexane is 600 grams. So we have to change this one into kilogram. So on how to change this one for the kilogram. So I don't have any pen here, so I'm gonna explain it on how. So 600 grams multiplied by 1 grams divide 1000 grams, we get the answer of 0.6 kilogram. So we have to cancel the both grams, and then the only one is na naiwan is kilogram na lang. So we come up with 0.6 kilogram. And then we have to answer that on our scientific calculator. Of any calculator, we come up with 1.2335 molar solution, or we can round off it. So we have 1.24 molar solution. Then after we get the smallest molality of solution, we can answer the working equation, which is the KBM. So we have to substitute the values. KB, we have KB here is 2.79, and we have the mole solution here is 124 or 12035 m. So we have to cancel m and m here, so we get degrees Celsius. So this is the answer that we have to come up, 3.45 degrees Celsius. So now, what is this? Knowing that the boiling point of pure cyclohexane is 80.74 degrees Celsius. So we all know for the given problem is boiling point of pure cyclohexane is 80.74. So pure pa lang na siya, kani pa lang na siya o cyclohexane 600 grams. If masagulan siya o lactic acid, pila naman. So now we have to add both on the we come up answer for the boiling point elevation is they are 80.74 degrees Celsius plus 3.45 degrees Celsius. We come up with the 84.19 degrees Celsius. So 84.19 degrees Celsius is a final answer. Try it number 2. What is the boiling point elevation when 250 grams of lactic acid is dissolved in 754 grams of cyclohexane? The boiling point constant for cyclohexane is 2.79 degrees Celsius per m, and the boiling point of pure cyclohexane is 80.74 degrees Celsius. So let's answer.
For the example number 3, we have the given of Kb for water is 0.512 degrees Celsius over m. For the boiling point of the solution, you have the 100.25, but the boiling point of the water is 100, so we just have to minus it. So we have to minus 100 degrees Celsius. It is equals to 100. So we have the only 0.25 degrees Celsius, and the mass of the solvent we have to convert it into kilogram. So 55 grams multiplied by 1 and divided it to 1000 kilogram, and then grams. So cancel, and you have the answer of 0.05 and 5 kilograms. So for the next step, we have this for the M, where the TB, and for the M we have to divide the TB and KB. So for the TB, this is the TB, the 0.25 degrees Celsius, and the KB is 0.512, so we just have to do it. So 0.25 degrees Celsius divided by 0.512 degrees Celsius over mass. Cancel them, and the answer is, so if we divide these numbers, we have the answer of 0.488281 and 25 m. For the N solute, you have this, the m divided by the kilograms. So this 0.488281 25 m multiplied by 0.055 kilograms. So if we multiply these two numbers, we have the answers of 0.260 and 9. For the final answer, we have the N solute multiplied by the molar mass. So we have the N solute, which is the 0.260 and 9, and we have the molar mass of acetone, which is C3H6 and O. We have the 58 grams over mole, so we have to multiply it. 58 grams over mole, and if we multiply those both numbers, we have the answer of 15.60 grams. So for the given of try it, example number 3, we have the given of Kb for water is 0.512 degrees Celsius over m, and the boiling point of the solution is 100.217 degrees Celsius. We have to minus it in 100 degrees Celsius because it is the boiling point of the water. So the boiling point of the solution is only 0.217 degrees Celsius. For the mass of the solvent, you have the 42 grams, but we have to convert it into kilograms. So we have the 42 grams multiplied by 1 kilogram and divided by 1000 grams. So we have the 0.040 and 2 kilograms. And for the molar mass of acetone, you just have to multiply and add it. So we have the 58 grams over mole. For the M, we have the TB over KB. So we have the KB of, for the TB, we have the 0.217 degrees Celsius, and for the KB, we have the 0.512 degrees Celsius over m. So we have to cancel it, and the answer is 0.42 M. And for that next one, for the N solute, we have the M multiplied in kilograms solvent, which is the M, we have this M, 0.42 multiplied by 0.042 kilograms. So this is where the kilograms here. So we have the answer of 0.018. And for the last part, we have the N solute multiplied by the molar mass. So for the N solute, we have here 0.018 multiplied by the molar mass, which is 58 grams per mole. And the final answer is 1.044 grams. I hope you guys learned something. Thank you.